We're going to look at another example of factoring two terms, and in this case we're going to be factoring the sum and difference of cubes like we've got in this example. So in this example you can see that x is cubed, 8 is 2 cubed, so we're going to use a formula for the difference of cubes. All we need to do is to figure out what our values of a and b are. Let me go ahead and write that formula down underneath this example so we are ready to go. I've got an a minus b. And then a squared, we change the sign, ab, and then it's always a plus b squared there at the end. So we need to figure out what got cubed. Okay, so it was an x here. That was cubed for sure. So that one's going to be an x cubed. And then for that 8 is a 2 cubed. So this tells me that a is equal to x and b is equal to 2. Let's go ahead and put those right into our formula now. So right into our formula, replacing the a and the b, the formula makes it so nice. I'm going to end up with an x minus 2. And then I want a squared, a is x, so that's going to be x squared, plus a times b, x times 2. I'm going to clean it up in my last step, and then plus a b squared, that's going to be plus 2 squared. So cleaning this up, there's not that much cleanup to do. I've got an x minus 2, x squared plus 2x, and then 2 squared is 4. Now you might be wondering if you can factor this one further, but as long as you checked for any GCF, any common factors between the x cubed and the 8 to begin with, you're guaranteed that this doesn't factor any further. Let's look at a sum of cubes next. For the sum of cubes, we're going to use a really similar formula, but I know that I need the values of a and b, so I'm going to start there. So x cubed, that's going to be x. That was cubed. That one's always like a little too easy, right? So a is going to be an x. And then for that 27 is a 3 cubed. 3 times 3 times 3 is 27. So that's going to be a 3 quantity cubed. And there's my value of b. So when I use this formula, it looks really similar to the last one, but you'll notice that where the difference of cubes starts with the difference a minus b, the sum of cubes starts with the sum a plus b. All of the letters are the same, but we change the sign now, so we get a difference next, and then always a plus b squared at the end. I'm going to put that underneath our example. And we're ready to substitute our values of a and b. That's my x and my 3. Okay, so here we go. It starts with their sum, so x plus 3, and then x squared minus ab, so that's x times 3, and then plus b squared, that's going to be plus a 3 squared. Simplifying this one, so I get x plus 3, not a lot to do, x squared minus 3x plus a 9, and this is our answer. The next example is really important as well as the last example. Let's get to that next one. So in this one, I do have an x cubed, but the 2's are not anything cubed. So the very first thing that I want to do always is to look for a GCF in all of our terms. And I do have a GCF in this case. My GCF, my greatest common factor, is a 2 that they share. So I'm going to divide both of these terms, factoring out that 2 in front. So I get a 2, and then my quantity, I get an x cubed left over. 2 divided by 2 is equal to 1. Now I'm ready to dive into that sum of cubes formula. This one's super nice. In this case, a is equal to an x and b is equal to a 1. Let's get that formula up here. So here's our formula, but I also have a GCF. So whenever you have a GCF, that's going to live right out in front here. So as I put everything together for our particular example, we have a 2 out in front, and then I'm going to do my a plus b. That's an x plus 1. And then my a squared is x squared minus a times b is x times 1. Plus b squared is 1 squared. Not a lot to simplify here, so this is going to be our final answer. 2 times the quantity x plus 1. X squared minus, you can write that as minus 1x, or just write that as minus x, plus 1 squared, which is 1. I've got an example with a fraction for you next. So just like I did with the last one, with any of these really, I want to start by thinking of a GCF. And there isn't anything that the 8x cubed shares in terms of a factor with the 1/64. So I'm ready to dive in with my values of a and b. And for those values of a and b, I'm going to think of everything just completely separate. So let's go ahead and start with the 8. So what cubed is 8? That's going to be our 2 cubed. So we've got a 2 here. And then how do we cube to get to an x cubed? That's going to be an x. So there's my value of a. I'm going to write it here. A is 2x. Now for the 1/64, I'm just going to break this down and I'm going to look at the 1 first. What cubed is equal to 1? That's just a 1. What cubed is equal to 64? I know that 3 cubed was 27, so that's got to be a 4 cubed. So 4 cubed is 64, so that's going to be a 4, and that's our b, 1/4. Here comes our difference of cubes formula. Let's go ahead and put our values of a and b in there. So I've got a 2x minus 1/4. Again, the difference of cubes starts with their difference. And then I want that 2x squared. I'm going to put this in parentheses here. So I've got my 2x squared plus a times b. A is 2x. B is a 1/4 plus that b, which is a 1/4. I'm again going to use parentheses, that entire fraction for b. I do have a little bit of cleanup to do here. So we get a 2x minus a 1/4, nothing to clean up there. Let's go ahead and square that 2x next. So I need to square the 2 and square the x. That's going to give us a 4x. So I get a 4x here. And I can think of this, now moving on to the 2x times 1/4. The 2x really lives in the numerator. So I can think of that as a 2x over 1. So I can cancel 2 divided by 4 is equal to a 2. So that gives me a 1/2 positive as my coefficient, and then an x, or you could write that as x over 2. And then finally, I'm squaring that 1/4. I really want to square the numerator and the denominator. So 1 squared is equal to 1. 4 squared is equal to 16, and that's our completely factored form. I've got more factoring videos for you. Take a look at this one next.